Hello, protocols, packets, and programs. We're closing in on 200 episodes, which is pretty exciting, until you realize how arbitrary and ill-behaved numbers can be. Sure, we've gone from 8-bit integers in the Commodore 64 to 64-bit processors, but all those integer operations might be signed, unsigned, underflow, overflow, wrapping, or saturating. And nothing will be as maddening as the first time you discover JavaScript uses 53-bit integers. Which means this week we talk with Steve Wilson from Contrast Security about delivering the tools that DevOps teams need to secure their current software, tackle tech debt, and adapt to the cloud. In the news segment, price of bounties versus costs of bugs, ICS vulns of 2021, a factory of secure software, a galaxy of cryptography mistakes, and more. Think of a number and stay tuned for Application Security Weekly.
This is Security Weekly, for security professionals, by security professionals. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. Imperva protects applications wherever they live and at the pace of development. From securing applications at runtime to protecting APIs in any cloud environment, only Imperva offers a unified solution across edge, application, and data to help you achieve more and save money. Start a free trial today and quickly protect your web applications at securityweekly.com/Imperva. This is episode 186, recorded February 28th, 2022. I'm your host, Mike Shima, and I'm here as always with Mr. John Kinsella. Hello, John.
Top of the morning to you, Mike. How are you?
I'm doing fine. Looking for those extra 11 bits for those JavaScript integers. We'll see if we can find them. John's in a good mood, possibly because everyone has been suggesting specific guests or topics that they want us to cover on one of our shows. Submit your suggestions for guests by visiting securityweekly.com/guests and completing the form. We review those suggestions monthly and we'll reach out to you once reviewed. And speaking of guests, today we have Steve, who is the Chief Product Officer at Contrast Security. He has over 25 years of experience developing and marketing products at multi-billion-dollar technology companies such as Citrix, Oracle, and Sun Microsystems. Prior to Contrast, Steve was the Vice President of Product Management for Citrix Cloud, where he led the transformation of Citrix products from traditional on-prem to SaaS. At Oracle, he led core engineering for a billion-dollar product line of systems management software. During his time at Sun Microsystems, Steve was an early member of the team that developed the Java computer programming system, the most widely used set of software development tools in history. Hello, Steve. Thank you for joining us.
Hey, thanks for having me.
So this is fun because we want to talk about building tools, delivering tools for DevOps teams, what they need. And, just going through your bio there very quickly, you've been building software development tools for quite a while, starting with Java, which I think people are a bit familiar with, especially on the, not your fault, but Log4j, of course, putting it back onto everybody's radar. But,
well, to be fair, the Log4j was such a big deal because everybody was using Java the whole time, but
in a lot of cases, they didn't even realize it, which I think, too, sort of comes to that theme of, we talk on this show a lot about bringing tools, Appsec tools, to DevOps teams and meet DevOps teams where they are. But a lot of times, I think we sort of skip ahead to, here's the tool for the team that's building with a modern CI/CD pipeline. But we might forget that, there's actually some tech debt, there's some legacy systems out there. And then looking forward, there's even cloud native systems that have a little bit of, different nuances to this, how this deployment process looks like and how tools perhaps need to be hooked into them. So maybe just kicking things off is, what's sort of the approach you've taken to tooling, and how do you see, adapting perhaps a single tool to those at least three types of audiences?
Well, I think when you look at the Appsec tooling that's out there, I like to joke Appsec is a multi-billion-dollar market full of tools that people hate. And, my own experience in this was colored before I came to Contrast when I was leading product for a large development team at my last job. And the head of engineering came to me one day and said, "Steve, I'm sorry, but I need to cancel the roadmap for next quarter." And when I told him I didn't think that was a good idea, he explained to me that the security team had just run a set of scans on the software and filed 1,000 Jira tickets for possible security vulnerabilities that needed to be investigated.
Ouch.
And by his math, it was going to take every single person on the engineering team, the next 90 days to even sift through it. And, the approach at Contrast has really been fundamentally different, that it's not about finding everything that could be wrong. It's about finding the things that really need to be actioned and doing this in a way that works in a wide variety of environments and for a wide variety of different types of development teams.
Yeah, I think that's just an AppSec team walking in, dropping that, dropping either the massive pen test report or here is just the slew of vulns definitely does not sound like the way to win friends. So there's one way, of course, to bring in the tools early. This is kind of, I think, one of those narratives. Bring in the tool early, have it so that the developers can see these vulns and understand them before the security team comes on later with a surprise, here's 1,000 and we're going to ruin your quarter. But I'm curious too, even as you start to onboard a tool, there's still this step function, if you will, where if the software hasn't been tested at all, hasn't had any security scrutiny, you're still going to get a ton of findings. So how do you even start with that initial rollout, that initial agreement or help between the AppSec team and DevOps that says, here's a tool. Today you've got zero tickets in that security queue. Tomorrow you might have 1,000 because we just turned on this tool. There's got to be a better way there.
So it's a classic question. It's one that I work with companies every day that struggle with this and how to approach it. And I think there's a couple things. When you look at these two camps of AppSec and development, they come at this with almost diametrically opposed goals if you're not careful, right? Where the AppSec team is focused on, I can't miss anything, right? I have to find every single possible avenue and chase it down because any chink in the armor could get me hacked. And on the other hand, you have the development teams, which are goaled on generating new functionality, getting that out to market, creating competitive advantage for the business. And you can go down the list from there and just find at almost every level, if you let these be two different camps, you'll wind up at totally different answers. And I think that's what we find with the tooling that's out there today, is this tooling was initially built for that AppSec camp. It was built by people who were AppSec experts as a way to automate what they do, the kind of investigative work that's done by an AppSec expert. It wasn't until really much more recently that people started thinking about the development teams. And there's a term that we like to use here at Contrast, which is your tooling needs to be pipeline native. It needs to be set up in a way so that you could run it in your pipeline. And that means that you need to be gearing this in a way where it's not about finding every possible avenue to chase down, because you will never get to them. You will never get through that 1,000 ticket backlog. History says it everywhere. But how do I find the most important things? How do I surface them quickly with really clear priority? And how do I get the developers really clear guidance on how to fix them, even if those developers are not security experts? And so really, when you start to say, I'm going to start doing DevSecOps and I'm going to pull ops into the equation, much the same way that we pulled dev and ops together in the last decade, you have to get away from the fact that we have two sets of priorities. You have to pull those priorities together, get everyone on the same page around what we're trying to do. And that, yeah, we have to be finding those high priority vulnerabilities and mitigating them. But we also need to be shipping software and doing it quickly and keeping the dev teams productive.
Yeah, I like that aspect of the idea that you were focusing that emphasis on the Appsec team finding. And I'm sympathetic to the idea that you want to avoid surprise, right, from the security team. You don't want to be surprised like, oh, wow, we actually had log4j in that dependency of a dependency of a dependency in this weird area. But that doesn't necessarily mean we need to fix it. And I think that was what you were getting at too, in the sense of, are there mitigating controls or what's the high risk? So I'm curious then, as we look at different pipelines, especially where pipelines might not exist. And here I'm kind of leaning towards legacy code, tech debt, where you have applications that haven't had a DevOps team that's been curating them, migrating them to whatever the modern pipeline looks like for 2010s or 2020. How do we turn on the scanning for the tool for that and go and secure that, or have a team kind of say, ooh, we're not even sure we can touch this code, let alone secure it better?
Yeah, so there's a number of different approaches to this. One says, look, if you're actively developing the software, whether or not you have the world's most advanced DevOps pipeline, almost every single team out there is moving to some kind of agile, where you're having to build automated testing. You can't exist in a modern environment with or without security, without the ability to do some level of automated testing and drive your stuff forward. The equivalent of that 1,000 Jira ticket bug backlog that I talked about was the old days when we used to postpone testing until after the software was done. And then what you get is a 6-week test cycle and 1,000 bugs that came back. That's how you wound up with death march software. But when you really look at really older legacy things, right? I've got this, Java 8 application that it's not actively being developed. How do I put some protection around that? And there's actually a lot of strategies that aren't run a scanning tool, find all the vulnerabilities and fix them. There are things like RASP tooling, where I could simply wrap a lot of protective armor around an application. And basically these RASP tools are tools that work at runtime that can actually, for an old Java application, for example, or an old .NET application, weave themselves into the application's bytecodes and actually look for the most common vulnerability classes and protect your application from them without you having to actually go in and modify the source code. So there's a lot of ways to approach this to get yourself protection without having to go and say, completely modernize the pipeline for some old legacy app.
Yeah, I think the message I hear from that is understanding, not having an Appsec team that's focused on, here's the tool that's going to solve our problems, more of, we have some security problems. What's the tool that's going to work with what the developers have access to, or how the developers are working within their either light touch because it's been neglected for a long time, old application, or their current pipeline that they're releasing every day, testing, and have a lot of attention to software quality. So that makes a lot of sense to me. I'm thinking too, I want to switch to, we're talking about the past. Let's turn, though, to the kind of cloud native apps we're looking forward, because you were talking about pipeline native, and I think that the cloud might introduce some additional hiccups, some additional different types of needs that these security tools have to pay attention to. And here I'm thinking of deploying straight into a Lambda function, for example, or multiple functions, or complexity of IAM permissions within one of these cloud environments. Is security tools and the cloud, is there a lot of messiness there that the tools have to adapt to, or am I just kind of misinterpreting some of what the future looks like for this cloud development?
No, you bring up a great point here. And, I think so many developers are excited about serverless functions, things like Amazon Lambda. And you see this next generation of, massively scalable backends, machine learning engines and things being built around the ability to do this very cost-effective event-based programming with things like Lambda. And Lambda itself has a lot of well understood security advantages in terms of, I'm not carrying around operating systems and app servers and things that need to be patched and updated. But at the end of the day, I still have code. I have open source code that I might be bringing into the environment, and I have my own code that I am writing. And all of those have security vulnerabilities as a possibility. And, if you go and look at something like the OWASP top 10, turns out there's an OWASP top 10 for serverless. And it's a lot of the same kinds of things are completely possible in that environment. Injection attacks, like the Log4j attack, that was actually also seen in Lambda environments. So you do need to protect yourself. But, in some ways, Lambda represents like kind of this massive fundamental shift in how you build distributed applications. And it's kind of the biggest disruption since Java servlets in the 90s, when we actually invented that app server paradigm. So your current security tools generally don't work in those cloud native environments. The applications are structured differently. They don't work the same way. Your sort of scanning tools that don't have access to the runtime environment can't see these details of what's going on there. And so when you think about the requirements in Lambda, you need a tool that understands a serverless environment, what it means, how it's connected into the rest of your cloud environment, and gives you the ability to find vulnerabilities in your custom code, find possible CVEs in the open source code that you're importing. And then there are these new areas like permissioning. When you're thinking about Lambda, it's almost like, imagine every function in your application is on the internet and by default accessible from anywhere. And that's why you have the ability to sort of restrict down permissions to give you that minimal set of permissions that's going to help you put boundaries around your cloud native environments and functions. And so your tool needs to be able to find those custom vulnerabilities, find those open source vulnerabilities, and manage the cloud environment with things like permissions. And that requires a new set of tooling.
One of the things we also you talked about earlier was related to this tooling is the Appsec team focus on, I want to find all the vulns, find all the flaws, but the DevOps side thinking, I have limited time, I want to fix the high impact ones, the ones that are going to be most likely to be exploited or have high impact to my system. As we talk about this cloud native approach, or even just serverless, adoption of serverless, are there successful strategies that you've seen where on the development side, there are better mitigation controls, better either designs or frameworks that have actually just adopting X, for example, from a development perspective, has made it that much easier to have to address fewer of these vulnerabilities that might be found from these scanning tools, or at least put on a longer SLA for fixing them. So rather than this might have been a high risk vuln that we have to fix within 24 hours, we can put it onto a 30-day backlog because it has a less impact because there's some property of serverless design patterns that we've adopted here. I'm not sure quite if that question makes sense, but I'm just grasping for something that devs can do from the beginning here.
Well, I'll give you the deep, dark, dirty secret of the sort of modern software development industry is with the Appsec tools that people have been using for the last 15 years. These tools are focused on finding anything that could be a vulnerability, not just a vulnerability. And there's very little difference between the two because just, for example, scanning source code, it's really hard to tell the difference. It is a computer science hard problem. And what that means is that your typical, Fortune 500 type company might have hundreds or thousands of applications, each of which has hundreds or thousands of possible vulnerabilities logged against it. So it's not just the case of, hey, introduce some tools and this might create a backlog. Everybody who's sizable has a backlog, and it's massive and almost to the point where it's daunting. And so often we see companies that have almost given up. They basically run the scanners as a compliance step that says I must run them. They generate a PDF and they file it. The thing that's really the mind shift is shifting away from having to find the full set of things that might be wrong, rather than the full set of things. It's how do I focus on the actual vulnerabilities and looking at the high priority things first. And so one of the things we've done at Contrast with our scanning technology is really clearly differentiated between things that are vulnerabilities and things that are interesting leads that a security researcher might want to follow up on that could lead to some interesting findings about the architecture of the application and things that could be done to strengthen it. By differentiating these, 90% of the cruft falls away, and all of a sudden, the development team can get much more focused. And when you look at adopting tools like IAST tools or interactive application security testing, where you instrument the code from the inside out, that actually, from a computer science perspective, is a much easier problem to solve than the code scanning problem. And so now what you get are real, true vulnerabilities where the developer gets a stack trace, a sample piece of data, and recommended fix instructions on here's the bug, here's the stack trace that triggers it, here's exactly where it is. You understand the severity, you get easy fix guidance. And what we find is if you give that to the developers, over time, they actually learn to avoid these things. And what you'll find over the course of a few quarters is that the amount of security vulnerabilities your development teams are generating goes down. It's almost like the same effect you had when you sort of built testing earlier in the pipeline. The developers got that instant feedback on when they created a bug. They just generate less bugs now.
So that's interesting, because you talked early on about, we need here's someone who says we need 90 days to take care of 1,000 bugs. And what you're describing there is, we've mentioned RASP, IAST as well. There is some development investment that has to be done to, hook up these tools, integrate them, get them working. What kind of expectations could a dev team have about, this initial, how much time they must set aside to do this integration of a tool, and how much of it can be maybe that an initial investment, but then over time it just drops off to a lighter touch maintenance mode while still getting, useful feedback out of the tool?
Yeah. So, we see this over and over again, where if you think about where you're going to set up this tooling, there are a number of places in your sort of development pipeline where you can think about plugging in. Something like IAST plugs in very natural in your integration test environment. You basically set up one of these agents once, and then anytime you run your integration tests become security tests. You don't even need a separate set of security testing. Then every time you run a set of code through your integration test environment, you get an instant set of findings that come back to you. And so that's this kind of day-to-day thing. What we found is with our code scanner, the way that we designed it with this kind of pipeline native thinking, you can actually put that in to scan the code on every pull request. And it's easy to set up. For example, if you're a dev team that's working in GitHub, we have a GitHub action that plugs right in. You don't need a separate console or anything. You literally just do a pull request, your code gets scanned, and the results show up right in your GitHub user interface along with the rest of your, kind of commit and build steps. And so you can make it a really natural part of a software development process that hooks in with the tools the devs are using.
How much time does that add to your GitHub workflow, though, or doesn't have to be GitHub, I get, but how, that's from my experience. When we bring a scanner of any type into these type of environments, the first question I get from a customer is, how much is this going to slow me down? So what is that approximately, do you think, for some of these tools out there?
So one of the things that we had to do with our scanner when we said it had to be pipeline native, there were two things that meant. One is it had to be super accurate, couldn't generate false positives. The other, it had to be blazingly fast. And so we have a scanner that's sort of 10 times faster or more than people are used to. So in reality, scanning a typical medium-sized application might take something like a minute, and you could do that synchronously, asynchronously. When you get really good at it, you can actually have those things gate commits or gate builds. Early on in the cycle, just do it as an informational thing. It winds up running asynchronously. It adds zero overhead. So it's really about how you want to plug that into your process. But, think of it as really, in some ways, no different than kind of running your current unit tests and things. It's part of the process and ultimately makes you far more efficient than not doing it.
That ties into an aspect of, I always like to ask about metrics. How do we measure something to show that we're being successful, that we had a hypothesis at the beginning and we need some way of testing it. One of the metrics, for example, on the Appsec side is how many vulns can I find? And actually, I'm not sure that I necessarily even agree that that's a good metric to chase, but I'm going to jump off that onto the dev side and kind of a follow-up on John's question. There's, I think, very obvious metric in terms of how fast can my build run? How quickly can I develop, or how long do I have to wait before I know that my commit succeeded, I can roll out to prod? So that'd be one type of metric. Are there other metrics that you've encountered on the dev side of things related to security or these types of tools that you see DevOps teams successfully use to measure their success at adopting tools, or even just addressing the risk, the security vulns that come through these types of pipelines?
I'll start at the beginning of your question, because we do see this over and over again. The idea that your security team is gold on how many vulnerabilities they can find is the root of all evil. It is the fundamental dysfunction in Appsec.
Thank you.
Yes. Right, because it would disincentivize your Appsec team from even training the developers on how to not create more vulnerabilities. It's fundamentally set up for overall team failure. Now, when we do get into what are some better metrics, one that commonly gets bantied about is I think it's really stolen this acronym from kind of a standard DevOps environment, but it's MTTR for vulnerabilities, which is what is the amount of time between when a vulnerability is discovered and when it gets remediated. And when you start one of these things, you go into an environment and you start measuring that for the first time, you could be really disheartened. The time could be measured in months or more. As you do move to these more pipeline native things, what you want to see is that time go down from months to weeks to days to hours to minutes. And it's really much the same as that DevOps journey, where when you realized, kind of in the old pre-Agile days, if your bug got from development to test, it was 10 times more expensive to fix. If it got out to production, it was 100 times more expensive. In the sort of modern Agile environment, those bugs get captured so far left that they're much cheaper to fix. And, the MTTR in one of those bugs is super short. The opportunity with security is to do that same thing. Push it to the left, make it so the developers are in control, so they get the data early on, they get really clear, actionable advice on how to deal with it. They can bang those things out in minutes. And so I'd say that's probably the single metric I'd encourage people to think about, which is not how many vulns can I find, but what is the time between when it gets discovered and when it gets fixed. And if you see that coming down, you know that the process is working.
Yeah, I think that's very reminiscent of, I was trying to look up a link real quick for the DOOR report, DevOps Research and Assessment. I can't remember exactly what it stands for. I like Nicole Forsgren and others who've been working on that, which I think there's coming out of DevOps, coming out of the SRE world. I think a lot of what you've been talking about, of what needs to change from Appsec side, I think is very much influenced about what the modern application development looks like.
I mean, it's, DevSecOps is one of those terms that's been on the cusp for years now, and people still aren't sometimes sure what to make of it. And I don't even know whether the term DevSecOps winds up being a keeper for us over the course of years. But the driver behind it is that everything that drove you to want to move to a more truly agile process where you push the end and the beginning close together is as applicable to security as it was to overall code quality. And if you treat them the same way, it can be a huge boost, not just to your quality or the security of your code, but also to your productivity, because modern dev teams have come to realize they can't keep shipping code that is full of vulnerabilities. It comes back to bite you. Log4j was an example where, again, there was a month in December where almost no work occurred in a lot of development teams because they were scurrying around trying to find that vulnerability and fix it. But the alternative is now you have, the US Federal Trade Commission coming to people going, you can't ignore this anymore. Not just Log4j, but these types of vulnerabilities, if they're in your code and you get hacked, you will get penalized, you will get fined. And going all the way back to like the struts vulnerability, 3-4 years ago, I think Equifax got fined more than $500 million for what happened with that one vulnerability. And something like Log4j was a lot worse. So we're going to see these, we're going to see them come up over and over again. So teams know that they need to be dealing with this. They're just looking for the best way to do it.
They do, and I'm trying to resist. You brought up struts, which again was another sin of Java. So I don't know, Steve. We might have to put you on the spot here and judge you for the crimes that have been committed from this emergence of the language. But I tease. Yes.
I'll just make one comment. Given that Contrast supports Java code, .NET code, as well as fancy new things like Kotlin and Go and everything else, is we've seen Go vulnerabilities in this past year that were just as bad as Log4j. They just weren't as pervasive. But if you're developing in a modern language, modern, trendy, cool language, you're just as open to all these problems. It just might not be as prevalent because you don't have as many apps written in that yet.
Yeah, and we even here, John and I have talked about, or maybe me more so. There's plenty of memory safety, sure, but to your point, we just in the last month or so talked about directory traversal vulns in Go. And Rust is not immune to logic problems, implementation problems. And then we can get into the whole idea of JavaScript or Solidity if we want to go that crypto space and what contracts look like in quote unquote memory safe languages. But I'm going to get excited and amped up here talking about all the different types of vulnerabilities that can happen in all the languages we can make up here. So yeah, I think you're very right here. Yes, John.
That's an interesting question I want to stick in there real quick. I know we're coming up to the end, and I'm not trying to put you on the spot, but does Contrast have you guys had, let me rephrase this, not so much do you have support for, but are you getting potential customers asking if you have support for working with the various crypto languages and frameworks? By which I mean coding, not cryptography.
I'll answer this really briefly, which is doing security scanning sort of for blockchain applications themselves isn't something we're seeing a lot of demand for. But, the overall blockchain space, when you think about, a crypto exchange or something like that, they're all web applications. They exist on the internet. They're vulnerable to all the same things. We saw one of the most visible hacks related to Log4j was a cryptocurrency exchange, and it wasn't that the blockchain itself got hacked. It was that their applications wrapped around it got hacked, and it was still just as severe and problematic. So we do see that the Web3 world, to the extent it's attached to Web 2, has all the same problems. It'll be interesting to see going forward what kind of new security tooling we need for Web 3.
We'll be curious, and especially you've been here since, I think it's fair to say Web 1 and the emergence of Java, which is pretty cool, Steve. So maybe just one final parting thoughts on, you mentioned, for example, the OWASP top 10 for serverless, and you gave us that MTTR type of metric. Any perhaps final bits of wisdom or something to look forward to for our listeners in 2022, whether it's on the side of vulns, the side of metrics, or the side of tools?
I think if I could send one message out to the viewers out there, it would be that whether you're today on the security side or the development side, there's a better state in front of you, where if you can get these stakeholders together, if you can get people on the same page around what the goals are, it will open up new levels of productivity. It will open up new levels of cooperation. Everyone will feel better about what they're working on. And we've seen this over and over again. We've seen this transformation at hundreds of companies that we work with. We know it's out there. And so really, if people can lean into that and stop being stuck in one particular silo of I'm in dev or I'm in AppSec, and everybody's really just about shipping secure software fast, there's a better world out there where we can have the best of both.
Yeah, that sounds like a great message to end on, and to good goals to continue to strive for. So I want to say thank you, Steve, for bringing us that message and a lot of other insights on deploying tools successfully.
Hey, thanks so much for having me. This was a blast.
Thanks for joining us. I want to thank John as well, and thank all of our listeners. If you'd like to learn more about Contrast Security, visit securityweekly.com/contrast. And now we're going to take a quick break and return with news of the week.